Good morning. My name is Kaori Muramatsu. Thank you everyone for coming. Let's begin. Introduction. Until now, dance research has been dominated by philosophical and literary perspectives, and it has focused on the symbolization of movement or image. On the other hand, choreographers so far have also been artistic craftsmen relying on the tacit knowledge of artisanship, and they created dances based on subjective rules of thumb. Scientifically, we have not been able to find a tool for clarifying the choreographer's tacit dance concept until now. So, in this study, we focus on Kansei engineering, which clarifies the human cognitive evaluation structure. Objectives. The purpose of this study is to confirm the cognitive evaluation structure of dance choreography, to systematize the expression of dance movements, to gain knowledge to develop future dance choreography concept. Kansei engineering methods were used for these purposes. Look at the figure 1. Let me explain a little more the figure relationship between impression evaluation and physical cognitive elements. Figure 1 shows the cognitive mechanism of ballet viewers. In this method, the viewer looks at the physical cognitive elements A, B, C, etc. of each silhouette and evaluates the impression. In other words, we are looking at a relationship between the physical information, which is the ballet movements, and the evaluation results of each impression word, which is the viewer's impression. The details will be skipped here. Rough set were used to analyze the relationship between impressions and physical cognitive elements. Principal component analysis was used for classifying impressions. These image groups will be explained later. Methods. Main method procedure. The following is a description of the main method steps. We proceeded in the following 3 steps. 1. Definition. 2. Survey. 3. Analysis. In the first step, we conducted the following tasks. In the second step, and in the third step, we will now explain the tasks of 1 through 8. In the first step, definition. 1. Creating the ballet pose silhouette. Dance videos by the leading female dancer from Swan Lake were analyzed. From these dances, 3 veteran ballet instructors extracted 19 important poses. The target dances were the 2 pieces of the solo parts of the female principal. They are from Act 2 Odette's solo as Swan role and Act 3 Odie's solo as Black Swan role. The silhouette image was created by binaurizing the still image of the extracted pose. Based on the silhouette's characteristics, a dummy variable table for rough set analysis was created. Next, we conducted 2. Extraction of physical cognitive elements. 3. Defining the attributes and attribute values. In this slide, both Table 1 and Figure 2 show about physical cognitive elements of ballet poses. From the silhouette images, 22 attributes and 66 attribute values of physical information were defined from A to X. Let me give an example of attribute A. Attribute A means the area of the silhouette. We calculated the number of pixels in the image and set the attribute values A1 large, A2 medium, and A3 small based on the number. The attribute value A3 indicates that the silhouette area is small. Based on these physical characteristics, a dummy variable table for offset analysis was created. 4. This table shows defining the impression and variation words. The 3 veteran ballet teachers consulted with researchers and decided on 20 impression words to be used in this study. We categorized and organized the impression words used in their previous research on dance and cancer engineering. 20 impression words were also used for principal component analysis and rough set analysis. The red boxes indicate impression words, and the blue boxes indicate image groups. Image groups will be explained later. Let's move on to the second step, survey. The tasks here are 5. Conducting SD questionnaire surveys, and 6. The date and time of survey. And the respondents are as follows. Here is the SD questionnaire form with 7-point method. Respondents were asked the following questions. 6. For creating the dummy variable table, silhouettes were divided into 2 parts based on the mean SD rating values. Next step, analysis. We will perform 2 tasks, 7 and 8. At first, about 7. We used PCA to classify the impressions, image groups. Details will be explained in the results. Next, we are talking about 8. In order to analyze the relationship between image groups and physical cognitive elements, we conducted rough sets. We used the decision rule analysis method. Also, we used the impression evaluation values from the SD survey. The analysis method is not explained here. Please refer to the references. Results of PCA. In this figure, we can see the relationship between silhouettes and image groups. At first, second, and third principal components were used to create the image groups, such as expressiveness, figuration, and aesthetics. We focus on the first component scores of the first principal component X and second principal component Y. I will not talk about the details here. Please see the proceedings. Results of rough sets, dynamic. Look at the figure 4. Combination patterns of impression variation and physical cognitive elements. I will explain dynamic, static, one of pairs of impression words. For example, the features of dynamic static were extracted as shown in this figure. The silhouettes were divided into two distinguished fields based on the SD mean value. On the left, dynamic, and on the right, static. I will explain dynamic first. The silhouette of H had the highest SD rating value. In other words, viewers evaluated H as the most dynamic pose. The characteristics extracted for dynamic were S1, R2, and J1. S1 means the distance between both feet is large. The characteristics of dynamic are related to the elements of stretching upward and raising the lower limbs high. Results of rough sets, static. Look at the right part of the figure. We will explain the static impression. The silhouette of D had the highest SD rating value for static. It means D is evaluated as the most static pose. In the static, 5 different combination patterns of attribute values were extracted, such as D3R3, E1R3, and so on. In the rough set decision rule, D3 means if R3 and D3, then static. R3 is the attribute value for distance between both hands is small. Also, it is an important core attribute value as it shares a part of multiple combination patterns. From these 5 extracted patterns, static impressions are characterized by not extending upward and hands rather closed. Results of rough sets, image groups. Look at the table 3. Relationship between image groups and body cognitive elements attributes. As we explained previously, we conducted PCA to divide the 20 pairs of impression words into 3 groups. The pink area is the expressiveness group of the first principal component. It is related to the attributes R, S, U, J, and M that compose the spread of extremities. For example, an attribute M in the pink rectangle is a core attribute between expressiveness image group and figuration image group. Using table 3, we can create the dance expression by selecting the attribute appropriate to your choreography concept. I won't go into detail here, so please have a look at the proceedings. Conclusion. The purpose of this study is to confirm the cognitive evaluation structure of choreography. We analyze ballet poses, which are one of the most important components of ballet expression. By using the relationship between image groups and physical cognitive elements, we can create a dance which precisely reflects choreography concept. Future tasks and references. Thank you for your attention.